In this video, we are going to discover three of the most important trigonometric ratios of mathematics, which is about triangle. So let's just start discovering them. First of all, you should know we have a triangle, and this is a right angle triangle because it has 190-degree angle at angle B, at vertex B, right? And the second angle, which is given at vertex A, is 45 degrees. Now, if you look at the three sides of it, you should know a right angle triangle has special names for all of its three sides. First, you already know that the opposite side of 90-degree angle, here we have a 90-degree angle. So the side which is opposite to it is this side AC, is known as hypotenuse, which is shortly pronounced as HYP. This means hypotenuse. This is the opposite side of 90-degree angle, and it is also the longest side among these three, right? The second name you should know is the opposite, and if you're talking about angle A in this case, so the side which is opposite to angle A is known as the opposite side. For example, this is the opposite side for angle A, right? And if you're talking about angle C, so the opposite side will be this will be the opposite side for angle C. But in this video we are having a benchmark angle of angle A, so we are naming the triangle accordingly. So for this A, this is the opposite side, so it is known as opposite side, OPP. And this is the adjacent side, which is just close side to angle A, so this known as adjacent, right? So these are the three names of sides of triangles: hypotenuse, opposite, and adjacent. Why we are naming the three? Because we want to use them in ratios so that we can easily use them in future. First of all, if you talk about the ratio of opposite over adjacent, O over A. If you look at these three, opposite over adjacent, we have here. So if you look at their values, this side is 3, which is opposite, and this side is also 3, which is an adjacent, right? So if you make the ratio of these two 3 or 3, so the answer will be 1. Okay, so what if we change the side lengths of this triangle like this? Okay, if you look at this, I am changing the side lengths, but you can see that they still are equal for 45 degrees. So the ratio of opposite over adjacent is always 1 for 45-degree angle, right? So this is the first angle. Now look for the second angle we can encounter, or something like we can do this. Okay, the second angle we can have is opposite over hypotenuse. This is the second angle, which is opposite side with a hypotenuse of the triangle. So if you can see the opposite side is 2.98. Here we have 2.98, and the hypotenuse is 4.22. If you divide the two, you will get the answer, which is 0.71. And again, if you change the side, you can take any side length, any larger side length, for example 7.47 and 10.51. Still, when you divide them, you will get the same ratio of 0.71, right? So that means this ratio is also shown for these two, opposite over hypotenuse. For smaller values, even 2.49, 3.53, so still the ratio is same, right? So this is the second ratio, which is opposite over hypotenuse. Now look for the third ratio. Okay, the third ratio we could have is adjacent over hypotenuse, or adjacent is to hypotenuse. So here we have this adjacent 2.98, and this is the hypotenuse of this triangle, which is 4.22. So you can see that the triangle has the ratio is still same, 0.71. So if you change the values, you can see that the ratio remains the same, 0.71. Though the values are changing, 8.95, 6.33, so we have different values, but when we divide, we got the same ratio. Isn't it amazing to see that this relationship among the three sides of right triangle? Okay, so this is just let me do one thing here. So just let me. Okay, so these are the three angles we have seen, and you can look for all of these three values. The first ratio is opposite and adjacent. The second is opposite and hypotenuse, and the third is adjacent and hypotenuse. You can see that they have the values of the ratios we have, and when we change them, you can see that the values of each of these ratios do not change, right. So the values are changing, the ratios are not changing. But if we change the angle we have right here, according to this angle, we are making all of these ratios. So if I change this angle from 45 to 30, for example, so you can change that, you can see that the ratios has changed. Now the first ratio, which is this opposite and adjacent, is 0.58, the second is 0.5, and the third is 0.78, or sorry, 87. And but if you the ratio is still same for this angle if you change the length of this sides of this triangle, right? You can take the any side, then you can see that the ratios are same if you do not change the angle, right? Again, we can take any larger angle than 45 degrees. So we have this angle of 65 degree. You can see that if you find the ratios among the side of this triangle, the ratio is different from that angle. But if you change the length, you can see that the ratios do not change the values for this angle. You can change the any length. So this is trigonometric ratios. We have three ratios, and those work for you need to take specify an angle according to which angle you are finding those ratios, and if you know the angle, you can easily find the value of that ratio. That is the fixed value. They do not change. Whenever you will find the 45-degree angle, you will always find these ratios. The opposite and adjacent will be 1, that means they will be equal. The opposite and hypotenuse will be 0.71, and so adjacent and hypotenuse. So you can, using this information of triangle, you can apply in your life, and you can use it anywhere you want. In the last of this video, I would like to share with you the names we have for these triangles. Okay, the first ratio we have, which is opposite and adjacent, it has a special name, which is the tangent, which is known as tangent. Okay, sorry for this. The first ratio is the name of this ratio is tangent. You can see this tangent means the ratio means opposite over hypotenuse. The second ratio, which is opposite and hypotenuse, is known as sine, right? And the third ratio is known as cosine. And why this is cosine? Because this is a complementary angle of sine. If you find, for example, this angle is 45 degrees, so this angle will always be 45 degree, because you know that the interior angles of triangle is always some added up to 180 degrees. And if you're taking let me just do this, if you're changing any angle, so the second angle will change accordingly, because this angle is fixed to 90-degree angle. So according to them, this angle will be 62 degrees centimeter. So if you're finding if you're finding the sine, so it will automatically be cosine of this angle. So that's why it is known as cosine. So these are the three angles we have, three ratios we have in trigonometry: tangent, sine, and a cosine, and they always same. We have explored. You can also go to GeoGebra. You can make your own triangle in your copy if you want, and if you will see, according to the angles, this ratio always same for all the triangle we have in our lives. So hope this is very helpful. In the next video, we will use this concept, and we will use these ratios to practice some skills on IXL. So do watch that video as well, and please mention in the comments below, do you like this video and do you want any improvement in it. Thank you so much.